Okay, it's still your favorite maths genius. All right, before you today, we be looking at a prime factorization method on how to find highest common factor. A prime factorization method on how to find highest common factor. So in the last video that was made on this particular matter, we used the factor method, and then we made it clear that factor method requires you first of all to find the factors, all factors. Take note, all factors of the given numbers. You find them out. You find all the factors. Say you have asked to find HCF of 24 and 36, for example. You find all the factors of 24. You find all the factors of 36, and thereafter you check out for their common factors, and then the highest among or the highest between will be the highest common factor. So today we are pushing further by showing to you on how to use the prime factorization method. There are different ways they say to kill a bird. So you have to now find the easiest way for yourself to kill that bird. What I'm saying is this: the factor method is convenient for little numbers. All right, it will save your time. Is yeah, when you are dealing with little number, it saves time. However, when you are dealing with larger number and you begin to use the factor method, you are going to spend a lot of time. So hence this method, the prime factorization method. Today we are asked to find the HCF of 24 and 36, and we need to use the prime factorization method. So I'm going to give two examples here. This is just a little, not so big. It's not so big. Yes, I'll give another example where we have probably 100 of numbers, like in hundreds. So there we see how efficient this method is. So let's go ahead. Now, when they say prime factorization method, all they are saying is that express each number as product of their prime factors. Now, the question is prime numbers. What are prime numbers? Because if you know what prime numbers are, you will definitely know what prime factors are. So prime numbers are numbers that have two factors. Prime numbers are numbers that have two factors. I know you know a common definition which says prime numbers are numbers that cannot be divided by any other number except one, and it's very right and very standard. But yet the common ground on all of this is that prime numbers have two factors, one and itself. So I also have a video where I explain very well on prime numbers. You should go back to the channel and find, and I made it clear on that particular episode that prime numbers start from 2. That is to say, 1 is not a prime number. The very first prime number is 2. Afterwards, 3. And then we have, we have 2, we have 3, we have 5, we have 7, we have 11, and so on. So I made the proof on how these are prime numbers. So if you have time later, you just go through the videos up there and you'll find such. So now we are going to express 24 as product of prime factors. They will express 36 as product of prime factors. From there, whatever we have, we multiply. Whatever thing that are common, we multiply together to give us HCF. Now, this is how it is. Now, how do we express 24? It means we are going to be dividing 24 only by prime numbers. So we are done dividing and you get the quotient 1. You express them in their product. This is what I mean. The first prime number is 2, not 1. So 24 divided by 2 is 12, right? 12, 2 can also go into 12. So it's not just about being it prime, it's about being it a prime factor. So I could use 2 because 2 is a prime number, and the same way 2 is a prime factor of 24. What I mean is that 2 is a prime number that can divide 24 without leaving any remainder. 2 is a prime number that can divide 24 without leaving any remainder. So because of this, I could use 2 to divide 24, and then it gives me 12. Of course, 2 can still go into 12 without leaving a remainder. I can use it again. 12 divided 6. 2 can still go. That will give me 3. All right. So now 3 can go, and that will give me 1. For educators out there, for math educators seeing this video, I don't recommend this for lower grades. I don't recommend this for grade 3. I do not recommend this for grade 4. Yeah, you can push it in for grade 5, because grade 5, the child has already been taught prime number, so the child can easily use this. But for grade 2, for grade 3, for grade 4, they haven't been taught prime number. It's not yet in their curriculum, so the child will find great difficulty to sorting this out. So I haven't gotten here, so you write 24 will be, you express it as product. 24 equal to 2 times 2 times 2 times 3. The same thing here will happen to 36. 2 is the first prime number, and yet 2 is a factor of 36. That will give me 18. 2 again can go, it will give me 9. 2 cannot go again, in as much as 2 is a prime number, but yet it can't go into 9. So the next prime number to use is 3. It gives me 3, and 3 again, it gives me 1. So as product, we have 2 times 2 times 3 times 3. So let's take it up here. For 24, we have 2 times 2 times 2 times 3. For 36, we have 2 times 2 times 3 times 3. So at the end of it all, we have these as common products, another common product, okay, another common product. So at the end, we have 2 times 2 times 3, and that's equal to 12. Of course, 12 is the greatest number that can divide 24 and 36 at the same time without leaving a remainder. It means 24 can be divided by 12 to give you 2. 36 can be divided by 12 to give you 3. So you want to just digest a little, and then I give another example of a larger number. Still on the issue of prime factorization method. And then we have the question which says we should find the ACF of 120 and that of 100. Okay. Now, this is the reason why I said that the factor method is limited to smaller numbers. If you want to use the factor method for this method, you are going to just consume your time, and then you'll be, you'll be weighed out. It will be stressful for you. So what you do, you use the prime factorization method. Okay. So let's go. The very first prime number is 2, and yet 2 can go into 120. Of course, 2 can go into 12, it gives you 6. 2 go into 0, gives you 0. So 2 go to give you 60. 2 can go again, you have 30. 2 goes again, you have 15. Right? But can 2 go into 15? No, there's no number you multiply by 2 that will give you 15. How about 3, which is the next prime number? Yes, there's a number multiplied by 3 that will give you 15, which is 5. So 3 into 15 will give you 5. Of course, you already know at this time that 5 is a prime number, so no number can divide it except itself. So at the end of this, we are going to have express 120 as product of its prime factor. We are going to have 2 times 2 times 2 times 3 times 5. 2 times 2 times 2 times 3 times 5. So let's do the same thing for 100. 2 can go, it gives you 50. 2 go again, it gives you 25. But 2 cannot go into 25. First of all, 25 is an odd number and 2 is an even number. Another reason, there is no number you can multiply by 2 that will give you 25. What about 3? There's no number you multiply by 3 that will give you 25. Then the next prime number you consider is 5. Of course, 5 times 5 is 5. Then 5 goes into itself 1. All right, you see that? So let's express this. 2 times 2 times 5 times 5. Let's take it up there. 2 times 2. 2 times 2 times 5 times 5. All right? So then the common product here is 2. 2. Of course, we have 1, 5, 1, 5 here. You see it, 5, 5. So right now we are having 2 times 2 times 5. And that is 2 times 2, 4. 4 times 5, 20. Of course, 20 is the greatest number that can divide 120 and also divide 100 without leaving a remainder. 120 divided by 20 is 6. 100 divided by 20 is 5 without leaving any remainder. So I think we draw the curtain here, allow you to take this in and do way to ask your question. Do it to ask questions, do it to drop your comment there. If your comment is coming as an appreciation, thank you. If it's going to come as questions, we are much available. In fact, we expect more of the questions. We expect more of your questions so we can get our feedback. Like I said the other day, we have a very strong feedback policy. We have it here, and it's working. It's working. So when you drop your question, you will get prompt response as much as possible. So just before I get your question, stay studious. school resumes or school does not resume, stay studious, engage yourself, give yourself more tasks to do, and then you just see the best coming out from you. God bless you. Bye for now.